Alright guys, welcome back to this learning module. Today we're going to talk about the downfall or the bottleneck of normalized data pipelines versus the advantages of using denormalized data pipelines when we are building our data models. Alright. Now as we can see here, there are few challenges that we are facing when we are using a normalized data pipelines when building our scripts, because the script design is just only to cater for the current user requirements, right? And there's no specific rules on how to script. Every developers can design their script based on their own unique way of creating the scripts. And lastly, we have to look through all the scripts again whenever there's new requirements coming in. Alright? Now let's get into details on each of the items here. Alright? So first item here, the script is designed to cater only for the current user requirements. Right? As we can see here, if there are 4 requirements that has been captured in the current situation, we are going to create each of the scenario line by line here, alright? So in this scenario, what if there are future new requirements coming in? For example, requirement 5 coming in, requirement 6 coming in, requirement 7 coming in probably next year, next 2 years, alright? So if this kind of scenario happens, we have to revisit the script again and again to cater for the new requirements. Alright? Now let's move on to the next item in the list. There is no specific rules on how to script, right? So as we can see here, the first requirement has been developed by the first developer, right? Second requirement developed by the B developer. Subsequently, the third requirement developed by C developer, right? So as we can see here, all of them are creating the script in their own unique ways. The first developer using an asterisk to load all the columns within the table. Second developer prefers to load in all the columns one by one. And for the third developer, instead of following the naming convention like the one did by developer A and B, it creates its own new table naming convention, right? Instead of using mapping A or B, it creates its own new table naming convention, map D, alright? So this will be very confusing when we are handing over this project to new joiners in our team, alright? Moving on to the third item in the list, developers can design the script based on their own flavors, right? So as we can see here, instead of placing all the mapping load script in one section, developer B prefers to create the mapping whenever he wanted to be applied in the fact table, alright? So there will be a lot of different scripting methods that has been applied into this one ETL layer, which might be confusing the next time when we revisit the script again for new enhancement or new requirements, right? Now the last item here is we have to look through all the scripts again whenever there is new requirements coming in. So for example, in this conversation here, our business analyst wanted to know if the dashboard contains fields B and E, right? And the BI developer couldn't give a direct answer because he has to look into the script again, alright? And after all the checking, it might take up a couple of hours to look through all the scripts just to only identify which columns are available or not available in the specific dashboards, right? So this is very time consuming for the BI developer to go through all the dashboard again, and it might actually create an impact or it might delay the timeline of our project, right? So a normalized script actually follows the waterfall methodology whereby it is actually a one-directional workflow. Alright? So as we can see here, the extract layer is very important for us to continue with our transform layer. And lastly, once our transform layer has been completed, then we can move on to build our application layer. Alright? So whenever there's new requirements coming in, we have to go back to the extract layer to check if the required mapping has been extracted into QED formats. Alright? And when this happens, this will actually imply extra efforts to complete our project. Right? So yeah, that's all about having a normalized script in our data architecture. In the next module, we're gonna look at what is a denormalized data architecture and how can a denormalized data architecture handles all these 4 problems that we're having here effectively. Alright? So yeah, that's all for the lesson today. Thanks for watching this video and I can't wait to see you in the next module. Thanks and bye bye.